Hi guys, today we are going to solve the 45th problem, Jump Game 2. That says, you are given a zero index set array of integer nums of length m. You are initially positioned at index 0. Each element nums e represents the maximum length of a forward jump from index e. In other words, if you are at index e, you can jump to any index e plus g where 0 is lower or equals than g, and g is lower or equal than nums e, and e plus g is lower than n. Return the minimum number of jumps to reach m minus 1. The test cases are generated such that you can reach m minus 1. Okay, in short, you are given a list of numbers, for example, 1, 1, 1, and you're supposed to get the shortest path from the start index, to the last one. So, for example, from this element you can jump to this other element, and from here you can jump to this element. But if you are given 2 at the start, you can jump from the start to the end. So in this case you are jumping only one time, and in this other scenario you are jumping 2 times. So in short, you are supposed to get the shortest path from the start to the end. And by the way, no matter what, you always are going to reach the last index, the last element. To solve this problem, what we are going to do, first you are going to create a pointer at the position 0. Then you're going to create the variable jumps. Then you're going to check if your index plus position index is greater or equal than or least length minus 1. If it is, you're going to return jumps plus 1. So here you have you are currently at index 0. You are at index 0, and your value is 2. So 0 plus 2 is greater or equal than, we have a length of 3, so is greater or equal than 3 plus 1, yes, and then you just are going to return jumps plus 1. In this case you are going just to return 0. And let's see the example below that I have created for this scenario. You have this list of numbers. These lines represent where you can go. So from the first element you can go to the third element, and from the third element you can go to the end or list. So in this scenario it is really easy to know that the minimum jumps you can do is from the first element to the fourth, and then to the end. But how can you check that? Well, you also need to create a variable that holds the current farther you can go. So current farthest, that is going to be 0 by default. And also you're going to create a variable that, okay, so this current farther, it represents the farthest position you can go in currently. So currently the farthest you can go is to the position 4, but if you were here you can go to this element and from this element you can go to this another one, and here you can go to the end. So this will represent the current faster we can go right now. And after that, you are going to create a variable called current end that by default is going to be 0. Okay, why we are creating two variables? Because first you check if you can reach the end. If not, if you can reach the end, you are going to traverse all the items from your current position to the farthest you can go. And for each iteration, for each movement, you are going to choose the current farthest between the element you are pointing at the element you have already to your current farthest. And once you have reached your current end, you are going to increase your jumps by 1, and you are going to put as your current end you're going to put at your current end your current farthest, so here. So let's do it. Okay, first, can you go to the end? No, you can go to the end. So is actually, let's put the conditional. So if your pointer equals your current end, you are going to increase your jumps by 1 and put your current end to your current farthest. And here you are going to compare your current farthest equals the max between your current farthest and your pointer plus your nums at the position pointer. Okay, so let's do it. First, can you reach the end? No. So your current farthest will be the max between your current fastest 0 and your pointer plus num. So actually my current farthest will be 4, and then 4. And then if your pointer equals your current end, you are going to increase your jumps by 1 and put your current end to your current farther. Remember that our current end actually is 0. So we are going to put as our current end 4, and then we are going to increase your jumps plus 1, so jumps equal 1, and put your current end to your current fastest. So our current fastest is this one, then our current end will be also our current farthest. Okay, so let's continue moving our list. Now we can go even farther, so we are going to replace here, and now we can go even farther. No, actually we cannot go farther. Now can we go farther? Give me a second. From this position we can reach here, and from this 6 we can go to the end plus 1. So let's say I don't know how many items are there, so n plus 1. And now your pointer equals your current. So if my pointer equals my current, yes, you are going to increase your jump plus 1 and put your current end to your current faster. So current end, so ends plus 1. Okay, then you are going to check if our index plus or list is greater or equal than our list of number minus 1. It is, then we are going to return true. So I'm sorry, then you're going to return jumps plus 1. Actually, this was supposed to be the first thing we do here. So in that, we are not going to replace any variable, forget that. Okay, so to do this in code, we are going to just do something like this first. Okay, let me comment this. Okay, first create our pointer at position 0. Let's pointer position 0 and create also your jumps equal 0 to or current farthest, that is going to be 0 2, and we are going to traverse or loop as long as pointer is lower than nums.length pointer plus plus. Okay, then check if our index check if our index plus leader position index is greater than or okay. So first check if your pointer plus your nums position pointer is greater or equal than your nums length minus 1. It's so you're going to return jumps plus 1. Otherwise, okay, you're going to first you're going to replace your current fastest. It will be the max between your current faster and your pointer plus your position pointer. Then you are going to check if your pointer equals your current end. So if your pointer equals your current end, and we have not create that value, so current end equals 0. Then you are going to increase your jumps plus 1, so jumps plus and put your current end to your current faster. So current end equals current fastest. Okay, and finally you're going to also return jumps but actually it won't be necessary almost never. Okay, so that should do the work fine. Yes, it's working, and let's submit this code. Okay, here is not working. Okay, output 0, output 1, okay, 0. Okay, I did something wrong here. So first our pointer dot length, oh, we didn't put -1 here. This is necessary in these cases. Okay, no, it beat 100% of all the cases, and it runs in 0 milliseconds. Well, guys, that's all for today. In a few seconds, you're going to see the solutions in Python, Java, and C++. That's all for today, and see you tomorrow for a new video. Bye bye.